Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to my lecture. So we already discussed about market efficiency. We also discussed about the equilibrium where demand function and supply function, they intersect each other. And then we also tried to understand how market gets fully optimized at the equilibrium point, where consumer surplus is maximized and producer surplus also is maximized. But at the same time, we also discussed it is not always true and important that to be at the equilibrium level where consumer surplus and producer surplus, they are at the optimization levels, because that also leads to market failure, because market is a place which which is always is like people are very unhappy about it, some they think that market could happen much in a much better way, or some will say that price mechanism in the optimization process should be happen in different way, and therefore market is always blamed by all the stakeholders. It could be by consumer or producers. In today's talk, the lecture will try to first begin with the Pareto efficiency, because that is where economists we always believe that Pareto efficiency is the perfect economic efficiency conditions, and that's how in economy it happens. And Pareto efficiency, it came after the name of Vilfredo Pareto, and Italian economist and social scientist. What do we mean by Pareto efficiency? So this is the kind of state where resource allocations happens, where allocation happens with a property that no one can be made better off without someone being made worse off, and this is what we call Pareto efficient or Pareto optimal. While doing so, there is also concept of Pareto improvement, which says that a change, Pareto improvement is a change that makes some, I'm highlighting some individuals, makes some individuals better off without making anyone worse off. So this is what Pareto improvement. And in Pareto efficiency, what we said that allocations, like no one can be made better off without someone being made worse off. So let us take the example of say public infrastructure, and say constructing bridge, right, or say highways. So obviously Pareto improvement, according to Pareto improvement, is like if that particular way it has bridge, and then constructing bridge, everybody will be better off, right, and not at the cost of anyone. So of course some people, individuals, better off, because those people who are using that bridge frequently or regularly, so definitely they will be at the better off situations without anyone makes worse off. Like constructing bridge, it is believed that no one will get disadvantaged after the construction of the bridge. But then it does not always it is true. Like if for instance, like the neighborhood nearby that highways or the bridge, if due to constructing of the new bridge or the new highways, if pollution, more cars are plying on that road or on the bridge, then there is a likely to have more higher level of pollutions, and then obviously people who are living along with the highway or along with the bridge, they will be affected. That is the one case. The other one case, of course, the sound pollution. If more vehicles are applying, then obviously there is a general tendency to have more sound pollutions, and therefore those people in the neighborhoods along with the highways or the bridge is basically uh, will have the sort of will suffer from the noise pollution. In this particular, both the cases of Pareto efficiency and Pareto improvement can be sort of taken as an example. So Pareto improvement, that is what one has to look for, like some individuals will be of course better off without making anyone worse off, and then the if we Pareto improvement, that should be like sort of instituted or formalized, is what is referred as Pareto principle. So these are the three concepts in context of Pareto efficiency that one can actually remember. This is how we actually think how resource allocation happens in case of exchange, in case of production, or in case of both. So so to continue our discussion, like we'll talk about economic efficiency, and there we will try to understand exchange efficiency, what do we mean by production efficiency, and then product mix efficiency, right? So some of the things we already sort of discussed, uh, and already we deliberated in context of optimizations. In case of consumer optimizations, we already know that the budget line or budget constraint is viewed as resource constraint, and indifference curve is the curve that actually shows the individual consumers utility functions. And then we also have seen that optimization conditions where utility is tangent with the budget line at a point where marginal rate of substitutions is equals to price ratio, right? Px by py will be equals to mrs for x and y. So we already know a couple of points, like in case of consumer, in case of producers we already know that in case of producers, iso quant curve and iso cost lines, and then we get the optimization points where marginal rate of technical substitutions is equals to the price of the input, a price ratio of the inputs, like here labor and capital. So now let's begin with economic efficiency. So let's recap what we already know. So if we take say consumer, and then here say y along with the vertical axis and x along with the horizontal axis, and then here is our budget line, which is nothing, is basically constraint line, and here say utility curve, which is indifference curve, utility curve of for x and y. And then we already know all these points. On any points on the utility curve will give the equal amount of utility, and therefore it is constant. And say at point E, which is tangent point, and then this is budget line, and budget line is like say pxx plus pyy equals to m which is constant, and at point E, which is equilibrium point, where we get optimum level of quantity of x and optimum level of quantity of y. And here at point E, where marginal rate of substitution between x and y, which is coming from utility, is equals to price ratio of x and y. So this is the kind of conditions that we are trying to highlight, that we already know, and this is optimization conditions, right? And this is how exchange happens between x and y, and substitution happens between x and y at the cost of, like, how much I'm giving up of y in order to get one extra unit of x. So now let's have a discussion on exchange efficiency with the help of Edworth and Bowley's box. So here we'll try to bring two individuals and two commodities, and then see how they actually intersect, and then how Pareto efficiency comes here, and who is getting and how much. So now let's draw, and then we'll write conditions later, because since we already know, like, this is our box diagram, and then on the left hand side, say O is one origin and O dash is another one origin. So yeah, say let's take let's take two commodities, and here maybe wheat and rice we can take, right? Like wheat, one commodity, and here is rice, and then how two individuals are actually sort of exchanging of the commodities wheat and rice. So this is like utility curve, utility curve for x. X is individual, O is the origin for, say, x demand for rice, and O is the origin, I mean here again, like vertically vertically moving from O towards wheat is basically demand for wheat for by x. Likewise, O dash is the origin for, say, person y, and then along with horizontal movement towards wheat is y's demand for wheat, and here y's demand for rice. So the same thing is basically utility for y. If you look at ux is the indifference curve or the utility curve for x person for wheat and rice. Like the substitution is between wheat and rice for x, but then if you consider y dash is the origin, and you can also kind of turn the diagram, the same property for the utility curve, like still, if I move along with the y, it follows the diminishing marginal utility properties, and this is the property for or utility function for y for commodities like wheat and rice. So all this utility, like say I'm getting the higher utility for y. So certainly y u dash is higher utility than y, and likewise we'll get this further higher utility curve for commodity wheat and rice for individual y. And likewise we have, say, here, like at u star y, utility utility curve for individual y, it is intersecting, or it is actually tangent with utility function or utility for individual y at, say, point E, which means like say OA amount of, at point E, OA amount of rice will be demanded by the person X, and then which means O dash A dash amount of rice will be demanded by Y. At point E, say OB amount of wheat will be demanded by person X, and then rest amount like O dash B dash is the amount of wheat will be demanded by person Y. But at point E, because here marginal rate of substitution for wheat and rice is equal between person X and Y, and therefore this particular equilibrium is a efficient Pareto efficient point. Definitely at point E, Y is getting much more higher utility. You can clearly see like utility curve for consuming rice and wheat is much higher. As it is moving up, it is much higher as compared to um, for utility for person excess utility. But then the first moving person will be person X. So person X will demand OA amount of OA amount of rice is required for person X, and then person B, and for wheat, in case of wheat, person X will demand OB amount of wheat, and then leftover like or the rest of the amount is like O dash B dash amount of say wheat will be demanded by the person Y. So at E, at point E, marginal rate of substitution between wheat and rice for X person will be equals to marginal rate of substitution between wheat and rice will be equals to each other, like for person Y, and then person Y definitely at E, again at E, Y is like person Y is having is higher utility. So this is in case of say exchange efficiency, where two commodities are are considered between two persons, and how utility will actually meet to each other. And then at point E, what we call exchange efficiency, like Pareto's exchange efficiency. So let's talk about the production efficiency. Again, we can actually see what we learned. Just to recap, like here say two inputs like for producing any goods like capital and labor, and this straight line is our ISO cost line, which means like wage per labor, and then here rate of interest, like here the total say total cost, and then this is our ISO cost, and this one is our ISO quant curve, and this ISO cost, like ISO cost curve is tangent at point E with ISO quant, and here marginal at point E, marginal rate of technical substitution between labor and capital will be equals to wage by rate of interest, means price, again price ratio of labor and and capital. So this is what, optimization conditions. Again, this is what we already, we already know this condition. This is optimization condition in case of producers, and at point E, producers will, optimize here, because OL OL star amount of labor will be optimally used by the producer, and OK star amount of capital will be optimally used by the producers to produce any goods and services. So now let's move to production efficiency with the help of Edward, Bowley's box, and then here the conditions that we'll put it, like say again box. So now say we'll be using capital and labor as input, and then in order to understand production efficiency, there are a few things. Like first is we have to see like how producers they are using inputs, like say on in this case, like say capital is measure along with this vertical axis, like from O towards this, and O dash for the other producers, and here say here this is like on the horizontal is like labor, and then say two individuals, like O origins for the say for the wheat producers, like say wheat producer. So choice will start from O, and O dash is the origin for say rice producers. So here, I mean, along with this horizontal is basically it's basically labor in input into rice, and here capital say input into say rice. Likewise, from if we move from O towards our right hand side is basically labor input into wheat. Likewise, if we move vertically from origin O, then it is basically say capital input into wheat. Like isoquant curve for say rice producers will be moving like this way. So it is basically isoquant curve for say for rice producers, and so Q2 is for the rice producers, and then here from O is basically isoquant curve for wheat production, and then here isoquant curve for wheat production, right? So and then again like Q3 and R. So this is like for rice producers, these are Q1, Q2, I mean Q1R, Q1, Q2R, Q3R are the higher isoquant curve for the producers, rice producers, and then suppose say Q star R, isoquant Q star R is tangent with isoquant curve 2, meaning Q2 for wheat producers at point E. So which means here like OA amount of labor is used by wheat producers, and then rest of the amount of labor which is like O dash A dash. So if total L is the labor or workforce available to produce rice and wheat, then here OA amount of labor is being used by the rice producers, and rest O dash A dash amount of labor is used by the rice producers, right? So optimally it is being used, but certainly at point E, um, rice producers are requiring more number of labor, and also also in the higher isocorn curve, like from the optimizations point of view, rice producers are getting more level up, kind of producer satisfaction from point E. So similarly, OB amount of capital, like say total capital available, so OB amount of capital will be used by the wheat producers, and rest of the rest amount of capital, which is O dash B dash, is capital that will be used by the rice producers. So in this particular production efficiency with this box diagram, that E is definitely is referred as the Pareto efficiency point, but certainly it is very clear that rice producers are using more amount of labor and more amount of capital, and in terms of optimizations, level of kind of satisfaction that rice producers is deriving is higher as compared to wheat producers. Say, and then another point at point E, marginal rate of technical substitution between labor and capital for say wheat producer is equals to marginal rate of technical substitution between labor and capital for rice producers is basically this. They are equal to each other. So this is what the condition, Pareto efficient condition is defined at point E. So now quickly go to product mix efficiency, where we already know what does that mean. So this is like say production possibility curve. So this concave curve is production possibilities curve, and here say this is utility, and say here at point E, where production possibility frontier curve is actually tangent to the utility, and here say two commodities like exchange between wheat and rice. So this product mix efficiency actually talks about 2 points. One is of course technical feasibilities, which is being represented by production possibilities curve, like feasibility for producing two commodities that we have considered like wheat and rice, and utility is the consumers preferences over commodity wheat and rice. So E is the optimum level up point where utility curve is tangent to production possibilities curve. So of course with this condition we get R star amount of rice, optimum level of rice which is feasible with a given production functions, and then W star is the optimum level of wheat production that at any given sort of given technical feasibilities for producing wheat and rice. So here I'll stop, and these are the references that are used in this particular class. So we already have given this three books like Jonathan Gruber, then Joseph Stiglitz, and Mancu's. These three books yeah, will be useful for you to understand further this Pareto efficiency if you want to go much into deeper with various other examples. So thank you for your attentions, and I look forward to see you in my next lecture.